Okay, fine. So we have seen earlier the methods of object class, right? So let's revisit them again. Yeah. So if you recollect, yes, what are the methods? I'll just put them again. Though we have somewhere earlier also we have listed them. Yeah. What are the methods? Right. I'll just put the method names rather than the whole method. Or okay, we can have the method signature as well. So okay, first one, yes, which was tried out, and whatever you can recollect. What was the return type? String. Method name? ToString. Okay, this was one. Purpose? What was the purpose? What was the purpose? String conversion. And it defines string conversion for objects of the class. What's the second one? Okay, I think we have one returns int. Name of the method was hash code. Okay, purpose. And so there is a hash code value associated with every object in Java. And so you can get what is the hash code value of the given object. Okay, fine. Third thing, returns boolean, method name was equals, right? So that we can compare for equality with any other object. And compare for equality. Okay, what is the fourth thing? Oh, this, if you recollect, we had it as a final method, right? And return type was class, name of the method was class. Okay. And return class object. Fine. But it returns the class object. Okay. Fine. I'm just listing them, so all of them we may not write the full description. Yeah. What were the other things? Protected. Okay. One is return type void. Name of the method was finalize. Okay. Fine. This is deprecated. When it has been deprecated, that means they discourage the use of this. They are saying, okay, uh, there is some better when don't use this method. Okay, this may be going off, and they may remove this method later. Okay, but then we have another method. Yeah, name of the method was clone. Yeah. Okay, fine. And okay, I think I had written this also, throws clone not. Yeah. So what's the purpose of this? Normally, right? Normally error at runtime. Okay, so normally it's giving error at runtime. What is that error? Right. So normally you have the clone not supported exception at runtime. Okay, fine. Okay, and it would return. Okay, normally throws this. unless okay, unless it is of clonable type, in which case it returns a copy of the object. Okay, fine. So this is something which is there. Other than this, there were 5 more methods. You recollect? Yeah. Okay. Public, final, void. Method name was wait. Okay. Related to multi-threading, so we are not discussing anything related to that. Okay, there's another wait where it has a parameter. Okay, the parameter is of type long, timeout in milliseconds. Okay, and if you want, you can be more you can be more precise in giving the timeout value. Okay, where you can even say, okay, so many milliseconds and additionally so many nanoseconds can also be specified. So your precision level can be up to nanoseconds. Okay, and then we have another public and final method, return type void, name of the method is notify. Similarly, there's another one which is the 11th method. Okay, fine. These are the 11 methods. Okay, fine. What we wish to use currently is this method and maybe these two methods. See, many of these methods you can see they are final. So what does it mean? What do the final methods mean? Okay, if we declare a method as final, it would mean that in the subclass this cannot be overridden. Okay, it cannot be overridden. Okay, now object class is the supermost type for all the reference types. Okay, so a subtype of the object, and maybe a subclass, if we are currently looking at classes, a subclass is free to override the methods. Okay, but which methods other than the final methods? Okay, and you can see which are not final. Okay, the first three, most commonly it is these first three methods which are overridden. Okay, there are cases where someone might even override the clone method if someone wants to allow cloning for its objects. Okay, unless someone says, okay, see, what is this clonable? I had mentioned earlier, it was nothing but name of a clonable is name of an interface. Okay. And we'll come across it later when we look at interfaces, but and we'll try to understand that. But mainly, any class you define, you would normally like to override these because string conversion, and one is to have proper string conversion, how objects of the class should be converted to a string. We have seen some output earlier where string conversion was done, and what was the string conversion? It was giving the name of the class at the rate and some hexadecimal number. Okay, what was that hexadecimal number? It was the hash code value in hexadecimal value, and as a hexadecimal. Okay, fine. It was the fine. So we know this. Okay, and what was equals meant for? To define equality of objects. Okay, fine. How do I compare two objects for equality? So first three, this is what we may have a look at. Okay, first three methods, and what we would like to do here is for all the classes which you define, normally you would override these methods. Okay, quickly let me see. We have the terminal on command prompt. Okay. Okay, fine. See, we have this tool JShell, right? Okay, okay, fine. JShell minus class path. And what's the class path? Dot dot backslash bit. Right? That's where the class files are. Okay, we have compiled yesterday. Okay, let's try to use an import here. Okay, we can say import and shapes. Okay, so it's unable to. Okay, shapes dot star. Okay, you have slash imports to know what all imports are available. So there are a number of imports which are already there, right? Okay, it doesn't list import java.len.star, but it's always there. Okay, fine. So some when it starts up, when you start JShell, yes, some imports are there. We have added the last import, which is nothing but shapes.star. So here, yes, we can use any of our classes in JShell here. Okay, fine. So if you wanted to see the string conversion, how we will convert into a string? First, let's create object of the rectangle class. So we can do it like this: rectangle R1 equals new. Okay, so let's create a 7 by 5 rectangle. Okay, fine. So R1 is nothing but object, but you can see this is what exactly is the string conversion. On the right hand side, what is being shown, that is actually the string conversion. Okay, how would you like it to be? Do you like it this one, or do you like the output which is actually given by this one? 7 by 5. Oh, here again, we have shown as shapes.rectangle, but probably we might not like to have the package name come in, right? What was the display method? Okay, we want to check that. What is there in the display method? Fine, let's check the display method here. Fine, we're just looking at the rectangle. Fine, currently we'll target the rectangle class, which is in the shapes package. So if you look at the display method, what is display method doing? Println, and here it has used get class dot get name. When we say get class dot get name, it gives me the full name of the class, which is shapes dot rectangle. Okay, there's yet another method in the class. Fine. This method get name is a method of class. Get class is giving us a class object, okay, on which we are saying get name, but we have another one. So get name, we understand what it is giving. In the case of rectangle, object of rectangle class, yeah. I started like this, right? So classes are in dot dot slash bin, so that's what we have. Okay, and then in order to use, okay, I'm just adding the import. Okay, on JShell, if you want, you can have a list of all the imports which are currently working. So you can say slash imports. Okay, that's a command. So to see what all imports are, so by default, some imports are always given in JShell. Okay, and so here I just want to add another import, which is shapes.star. Okay, and then yes, now what we can do is let's try using the toString method. Okay, let's see the string conversion, how string conversion is done. Okay, So for that, yes, what we did is we'll say, oh, we have a rectangle R1 equals new rectangle 7 by 5. Right? So what is being shown here is nothing but the output of string conversion. Find shapes.rectangle at the rate and some hexadecimal value. Okay, that hexadecimal value is nothing but the hash code of the object in hexadecimal. Okay. So if you want, we can see R1 dot hash code. Okay. And this will show the hash code value. So, but this is in decimal. Okay. So this, if you convert to hex, that's a hexadecimal form, 145144719. That's a hexadecimal value. Okay. So you can confirm like this. We can say, so I'm just showing you a few more methods. Integer dot to hex string. Okay. And you pass R1 dot hash code. Okay. So that will give you in hexadecimal. That matches the, right? So this is in hexadecimal, the hash code value. Fine. And if I use R1 dot get class dot get name and gives this name. So get class is giving me object of the type class, on which, just like we have a method called get name. Okay, that's a method of the class. There is also another method called get simple name. So that should give me only rectangle. Okay, right. So now string conversion, instead of the way it is happening, okay, I would like to see something similar to what display is giving me. Of course, I don't want that shapes dot thing, right? And we don't want that. We just want to see it as rectangle colon and whatever is the length by width. Okay, that is ideally what we might expect as a good string conversion for rectangle class. Okay, fine. So this is what we are interested in. Let's go to the terminal, to our code. Okay, this is the code for the rectangle class. Let's see how we can do this. So yeah, we can change in the display, but now let's change the string conversion. If you want to change the string conversion, how we do that? Currently, the method toString from the object class is being used. Rectangle is a subclass of the object class, and we can override the method. Whenever we write any overriding method, it's a good practice to have annotation called @override. Okay, and since it's a public method, here also we'll say public string toString. Okay, right. And yes, how do we go about it? We have to return a string. What will be the return string? We can say get class dot get, maybe we use the get simple name plus colon plus and then whatever is the length. Okay, you can say this dot length. Okay, and on the next line I'll continue. So plus we'll have x. Yeah, see, so I think what we are doing was we're looking at the string conversion. Okay, for rectangle class. Fine. So by default we have seen what string conversion happens. Okay, so fine. Instead of that, yes, we are now saying get class return. So the toString method, that's the one which we need to override in order to define string conversion for objects of our class. Okay, fine. So whatever by default we are saying, that's because of the method from the object class. Here we override, so for objects of rectangle, this will become applicable. Okay. And so, yeah. So what we are saying is, I put another, okay. In the class, there is also a method called get simple name. So instead of saying get name, which is giving the fully qualified name, you may just use the last part. Okay. So you can say get simple name. Okay. And then plus colon and then the length, and then we want to have the plus this dot, right? Okay, so this is what can be returned here. Okay, and let's see the output. Okay, so if you want to see the output, yes, what we'll have to do is either we exit JShell. So yeah, we'll have to exit the JShell. And first we'll compile. Oh, we have put it in shapes, right? Okay, fine, we'll compile this, and now we can quickly see it in JShell also. Okay, let's use the earlier statements. So we have, okay, yeah, we can just use those import. Okay, and then let's create the object. Okay, fine. Now you can see this, what happened. Okay, the string conversion has changed. Okay, so this is according to the toString method. Here, the string conversion. See, if someone says R1, or someone just tries this expression, says R1 is plus R1. You know, this is a string conversion. See how it appears. Clear how string conversion is happening? We can, so for whatever class you are defining, for their objects, a string conversion, right, you can take control what it should give. Okay, so it's the one who is defining class, he decides what the string conversion is. Okay, same way, the other method, yes, if you want, we can use a method called equals to define equality for objects of the rectangle class. Okay, see, we have one rectangle already, right? This is let's have R2 equals new 7 by 5 again. Okay, R1 is 7 by 5, R2 is also 7 by 5. Okay, you can just say R1, so that should win. You can just ask R2. And in JShell, yes, you can do like this. And check out what is fine. You and for any class, yes, you can test. Okay. So now you know these are both same thing. What would be the result of R1 dot equals R2? True or false? What is it that you expect? R1 equals R2. Are R1 and R2 equal? They are both 7 by 5, right? So for us, yes, they should be equal. What do you expect here? True or false? And the answer is false. See, what do we expect if I say R1 double equals R2? True or false? For this one, we would expect false because they are two distinct objects. Right? The double equal to, whether it's the same object? No, they are not the same object. But for this one, no, this doesn't look correct to me. Right? This doesn't look correct. We would like, oh, if their length and width match, then they should be marked true. It should return true. Okay, and this should be returning as true. And therefore, let's change this. Let's override even the equals method. Let's define, Because what is the default equals method? Okay, fine. By default, the equals method so by default, right? Okay. Okay, so that's how it is, right? Okay, it will be giving you same result as A equals B. In fact, if you want to get, I'll just show you what kind of code is there for the equals method in the object class. In the object class, equals method has been written like this. Given any object, O, okay, okay, there are a few checks, but there are initial check whether O is null or not and all those. Okay, a few checks like that, but it simply says return A. Fine. This double equal to O. This is the how equals method has been coded for object class. Okay, so unless you override equals method, fine, it's not going to give you equality. It's just going to give you whatever is there for double equal to. Okay, fine. So how we might like to override the equals method? So let's override equals method here for the rectangle class. Okay, now there are a few things which have to be taken care when we override equals method. A few things. See, we are defining a class which is going to be used by others. Okay, everyone is going to be using whatever class you define, right? It's a data type, right? So we have to ensure that this follows the general rules which are expectations from others. What are the expectations about equals method? And we'll see that also. So we have boolean equals object O. Okay, yeah, so this we will be overriding. But what are the expectations? So for the expectations, let me show you what are the expectations here. Okay, okay, what are expectations? And given objects A and B, okay, given two objects A and B, fine, what is expected? Fine, if you are saying A dot equals B, okay, fine, okay, it should return false in case B is null. Okay, if the given object is null, then whatever is the parameter, if it is null, it should return false. Okay, A equals B should return, it should return true in case, okay, A double equal to B is true. So we have, when we override, we have to ensure this. Okay, also few more things. It is expected that if A is not null, A equals A, okay, will always be true, where A is not null. Okay, another thing, given that A equals B is true, if A equals B is true, we see this is nothing but transitivity, and where A, B, C are not null, okay, and B equals, or okay, this is reflective, yeah. If, or sorry, I should say like this, A equals B should give the same result as B equals A. Okay, so whether I say A equals B or if I say B equals A, they must give me the same results. Okay. And other thing was, if we have, okay, this is about transitivity. Given A equals B is 2 and B equals C is 2. If this is the case, okay, if both are true, then okay, A equals C should also be true. Okay, so transitivity, that also symmetry, this is symmetry, and transitivity, this is to be ensured. This is your identity. Okay, and so all of these have to be ensured. Okay, so that's how you should be anytime you override equals method. And please try to ensure this as far as possible. Okay, let's see for rectangle class, how do we now override the equals method? Yeah, so what's the first thing? If the given parameter is null, it should return false. So you can just say if O equals null. Okay, that's how you can check for null. Okay, if the given object is null, right? Okay, so normal practice is to use blocks for even single statement. Okay, that's a normal practice. Okay, but it's not a must. Okay, so return false. So if someone wanted to finish in shortcut, then maybe I'll write it in shorter. And so, and since we're over, okay, and so this is the first statement. If it is null, then false. What's the other one? If O double equals this, return. Okay, first two things have been ensured. Okay, now what's the next thing? Okay, when do we consider two rectangle objects to be equal? If their length match and width match. Fine. Now for one thing, what we would like to also ensure here, if the given object is not a rectangle, then it's not equal. Okay, so let's see, how do we go about checking this? If O, or rather I'll say not, okay, let me say not O instance of, if O is not an instance of a rectangle, okay, in that case again return false. And so this is giving me false for anything not a rectangle, because this is in the rectangle class. I am making comparison. If the given, you are not giving me object of a rectangle, then I am not equal. Okay, and then okay, so if I have ensured or at least it's a rectangle, then I can do a cast to a rectangle. Okay, so we can have a local variable here, just a reference being created. So you can say, okay, rectangle R equals cast into rectangle, okay, O. I can just cast O as a, so R is nothing but, because the type for O is object, I want to now use it like a rectangle. It has been ensured that it's at least a rectangle. With the previous statement, right, in that line 71, right, that statement ensures that it's a rectangle, and therefore if I do a cast, this is fine. Now I can just check if, so R is referring to the object, whatever is O. R and O are same. Only thing, type for O was object and type for rectangle is R. Okay. So now if I say if r dot length is not equal to this dot length, okay, return a false. Same way, if r dot width is not equal to this dot width, return a false. If it has passed all these tests, right, then I can say yes, it's a rectangle. In that case, I'm returning true. So in this case, now they are equal because lengths have matched, width have matched. It has gone through all these tests. Okay. It is not null. It is not the same. If it is the same object, okay, anyway, it's returning equal. Okay, but otherwise, oh, it is not a rectangle, then not equal. Right? So it is a rectangle. This ensures it's a rectangle. Okay, this ensures the length have matched. This ensures the width have matched, and then that's sufficient for me to say they are equal. Okay, so we can have equals method being overridden like this. This is for the rectangle class. Okay, this is for the rectangle class. Fine. We can do similar thing for the cuboid class, which is using inheritance. When we have a cuboid class which uses inheritance, even for that we can write a similar code. Okay, fine. Now, one thing what I would like to know here is, suppose I do a similar thing for cuboid. How would the overriding of the method in cuboid, which is with inheritance, be done? Okay, maybe let's copy this into the cuboid class. Let's open the one which is using inheritance. Okay, fine, we go for the one with inheritance. And this inheritance, this is the subclass of rectangle. Okay. This is the one which is subclass of rectangle, and okay, it has these variables length and width. So here again, overriding of toString and equals, that can be done here also. Okay, first let's say public string toString. Okay. Public string toString. What do we return? Yeah, what do we return? We want to say cuboid, right, of length by width by height. Okay, fine. What is there in the superclass? toString method in the superclass? It's not rectangle. It is actually simple class name. Okay, whatever is the class name. When the same method, if it is used here, if it is used on the object of cuboid, it will say cuboid. See, why did we didn't hard code the word rectangle? Okay, because a subclass, and for a subclass object also, that toString method can be utilized. So here what we can write is, we can simply say super.toString. What will super.toString give me? Simple class name colon length by width. Okay, and so I'll just add by height. When this code is clear, how we have, when how this will be working. Okay, want to just check the output of this cuboid. Okay, let's compile and let's check the output again. Okay, so I'll exit from J shell and okay, we'll have to compile. And shapes, inheritance, cuboid. Okay, we have compiled and now we can use J shell with the class path. Import shapes.star. I can also have import. Now when I say import shapes.star, and I'm also going to say import shapes.inheritance. Oh, I should be writing cuboid. Okay, I'm going to write cuboid rather than saying star. Want to check what happens if I say star? Okay, let's try using cuboid. I'm not saying shapes.inheritance.cuboid, but if I just say cuboid C1, okay, equals new cuboid of 7 by 5 by 4. Shapes.star, oh, shapes also has a cuboid, and shapes.inheritance also has a cuboid. So what I should be doing is I can have import for cuboid. So this will be, this we understand. If you give this fully qualified, that will prevail over any wildcard. Okay? So before wildcard, this is used. So now if I try this, that's working for me. And you can see the toString. Clear the output of toString. Okay. Yeah, we have been able to use the superclass toString method while writing the toString of subclass. Okay, so this is one thing which we have done. Okay, next method. We also want to override the equals method. So now let's look at how we might be writing the equals method. Fine. So first things, okay, the first two statements may be similar to what we did for rectangle. Let me pick up from there. Okay, so this anyway can be picked up as it is. Okay, now what's the next thing? What should be the next thing? Do we want to do similar to what was done in the earlier case for the rectangle class? But instead of, okay, so if we want to check this, okay, maybe let's see how we might use this. And I'm just copying them and we'll update. Yeah. So if O, if not O instance of, instead of rectangle, maybe you might like to go for cuboid. Okay. In this case, here definitely I'll be casting for. Okay, the object is a cuboid object now. So equality for two cuboids. Okay, instead of R, let me say C here. Okay. So fine. No, we can't be accessing length like this. We will have to use the C dot get length method. Okay, and we may use the method in this case. And length has not been defined in cuboid, and anyway we are interested in the length from the superclass. Okay, because I think what we have done is we have a length as a instance variable in the local class. And I think, but the there is a get length which is, so even if you say this dot get length, that should still be okay. C dot get width. Okay, width is not a variable in cuboid, and therefore you will have to use the method. This dot get width, return false, and same way, what else will be there? The next thing is about height. Oh, super, no, it is only this dot height. Okay, fine. We may say get height. Anyway, get height is also a method, so we can use by using method also. Fine. So this should be a good equals method. Fine. Looks okay. Yeah. Fine. Okay. Fine. So what we have done is we have put this as a equals method. Fine. For the cuboid class. Okay. Just similar to what was done in rectangle. Okay. Fine. Two-string method was done earlier. Okay. This was done where we said okay. Fine. We have used super dot two-string in that case. Okay. So does this look good? This equals method? Or any problems with this equals method? See, what are the things we want to ensure, try to ensure? Given two objects, A and B, A equals A should be true. Okay, it is not null, right? Next thing was, A equals B should give me the same results as B equals A. Right? So A equals B and B equals A should be the same result. Okay, and that's another thing we want to ensure. Oh, is that going to be working? A equals B giving the same result as B equals A. Now, let's check it out. Okay, so let's compile the cuboid again. Okay, we have made changes in cuboid.java. Let's compile. So it's compiling. There's a new equals method now, right? There's an equals method available for cuboid. Now let's go to JShell and okay. In JShell, we will have the import import for the shapes and import for the cuboid. Okay. Fine. Let's create a rectangle object and the cuboid object. Let's see this. So we'll say rectangle R1 equals new rectangle of 7 by 5. Okay, and we'll have the cuboid object C1 equals new cuboid of 7 by 5 by 4. Okay, so now tell me R1 dot equals C1, true or false? What do you expect? R1 equals C1. R1 equals C1. So equals method for rectangle will be applicable here. We are calling the method on a rectangle object. So you may check the method as available for the rectangle class. Okay. So how is the equals method available for the rectangle class? Oh, that's here. And check the given object is a cuboid object. Oh, here is a cuboid object. Fine. It's null? No. Is it same object? No. So is it, if not, is this object of rectangle? What is O? Cuboid object. Is it a rectangle? Instance of rectangle will give me true or false? True. Okay. So it is an instance of rectangle. So this is true, and therefore I'll go ahead and do casting. Fine. After casting, is the length matching? Is the width matching? Fine. And therefore it will return true. Length and width are same. Okay. Fine. Okay. So yes, let's see this. So this is returning true. Okay. What about C1 equals R1? Does it give me the same result? What do you expect here? In cuboid, we are saying, is it an instance, that is a rectangle object in parameter. Is it an instance of cuboid? No. Rectangle is not a cuboid. Okay. Cuboid is a rectangle, not the other way around. Fine. And therefore, this is not giving us the same results. Fine. What we would actually like to have? Maybe the first one also should have been a false. It's not exactly a rectangle. Cuboid is not exactly a rectangle in our case, and therefore I would have liked that the first statement should also have been false. In that case, yes, A equals B will be same as B equals A. That thing will be established. So for that, let's see what is the change we can make. Okay, fine. In order to achieve that, yes. So the problem is here with the rectangle class. Okay. Now here, instead of checking, okay, instead of checking like this, whether it's instance of rectangle or not, we would like to check whether it is exactly a rectangle or not. Instance of rectangle would just say a rectangle or any subclass of rectangle is also fine. Okay. So instead of making a check in this manner, we'll actually do a different check. Okay. If this dot get class is not equal to something, not equal to O dot get class. Getting the class object, are they of the same class? This dot get class, okay. So what is this dot get class? The object on which the get class is invoked, which is nothing but the, in our case, we are thinking it will be a rectangle object, and O dot get class is O also of the same class. Are they of the same class or not? Okay, fine. So in that case, yes, this will be. So this is one change which I am making here, and based on this change, we can actually achieve a better thing here, where okay, I'd like to comment this out, and instead write one statement says, if not super dot equals O, return false. According to the superclass, just invoke the superclass equals method. When it goes for the superclass equals method, so it's in the rectangle class, but what is the object? Object of cuboid. The object is a cuboid object on which the method is invoked, and we are saying super. So here is O null? Okay, no, not null. Are they the same object? No. And get class not equal to O dot get class. What will happen? Are they of the same class? What is this dot get class when it is invoking super dot equals? This method itself will be called, but it will be called from the cuboid class. Okay, that means the object is of the cuboid class. So this dot get class actually is for the cuboid class. So O dot get class, if it is not a cuboid, for cuboid, okay, then it will be returning false. Okay, so it is, see this statement here at line number, this statement here is to ensure that they are the same type. The object on which method is invoked is same as the given object. The type for both of them is exactly the same. Okay, they are of the same class basically. Okay, it will be rectangle or maybe any subclass of rectangle, because any subclass may be using super and this method may be called. So method can be called even from a subclass. So what this here, when it says this dot get class, what this means here is the object on which method is called. It's not necessarily exactly a rectangle object, it may be a subclass of rectangle also. Okay, so I have commented it out and I'm using this one, and in which case, since I have done a super equals, it has ensured that length and width are matching. Okay, I will also not need these two statements. I won't need these two. So it's basically just those three steps, 1, 2, 3, and 4. Yeah, for the equals method in the cuboid class, subclass. Okay, now we can, if you want, we can compile and run again. Yeah. O dot get class return false. Oh, it has become capital O since. Okay, it's in the rectangle class, yes. This one. Okay, so this has compiled. Let's use JShell. Let's have okay, the imports. Okay, we can create a rectangle object. We create the cuboid object. Okay, and then we create the, then we look for equality, right? Let's look at the equality. R1 equals C1, and that's false now. Okay, and C1 equals R1. Okay, and so both are giving same result. And the idea is to let you know that if you are, yeah. So clear what is this get class doing for us? And, okay, so this dot get class is not equal to O dot get class. And rather than saying, so that rather than using instance of, because with instance of I don't get the exact match, it's either this or any subtype also qualifies. Okay. But writing code like this dot get class not equal to O dot get class just ensures that both of them are of the objects are of the same class. Okay, the current object, which is this, and the parameter object. Okay, so fine. So this is one thing which we have done. Okay, another thing which we actually have a problem with. Okay, Not we don't exactly have a problem, right? But there is a topic related to immutability. Right? It's normally preferred that when we have a class, the objects of the class should be immutable. Okay. Right? This is more related to concurrency, where concurrency is there. A mutable object, something where changes are allowed. Immutable means the instance variables, their values can be changed. Okay, so a mutable variable, fine, if it is there, yes, it is more likely to be, it will have problems when we use the same, when the object is shared in multiple threads. Okay, we are currently not looking at multi-threading, but just, so that is one, the idea is that yes, we should have classes whose objects are immutable. Okay, so in our case, in case of the rectangle class, okay, yeah, what is it that we have done which is not, which is actually ensuring that this is not exactly mutable? If you want to check that, oh, is it mutable or not, if I make this final and I make this also final, what would it mean? Length and width once initialized will not be changed. It is ensuring that they won't be changed. Then this is a class whose objects are going to be immutable. You know, where am I going to get errors? If I have assigned a value into length and width, if I have said this dot length equal to something or this dot width equal to something, and where have I done that? It's an instance variable which is final. Where have I done that? Oh, I have done it in the set dimensions method. So this is a method which will be a problematic method. Okay, so this is a problematic method. So maybe we might like to comment it out. I'm not doing it currently, okay? But this is where the mutation is happening. Other places, if I look at, yes, there is one more place where the assignment was done, that was in the constructor. But this is in constructor. For final variable in constructor, I would definitely be initializing. Okay, so this is not a problem. It's only the, for, if I want to make it immutable, I have to only comment out. I won't make available methods like set dimensions for anyone to use. Okay. This is something which we might do. Right? So this is one thing. Yeah. Okay. So once I have done this, yes, it is going to ensure that objects of my class rectangle are immutable. Okay. Let's try to test a few things here. And we'll compile. Okay, I'm compiling cuboid. Okay. But while compiling cuboid, it is dependent on the superclass rectangle. Rectangle will also get compiled. Okay. So yes, if I try J shell, and if I create the object of rectangle, maybe I just create rectangle object. And just create a rectangle object. Okay. R1 dot set dimensions. And that's an error. And we have commented out the set dimensions method. And so this is without the set dimensions method. Okay. So there is no way, given an object, any change, once it is created with certain length and width. Right? After that, on a given object, you can't make any changes. Length and width remain the same throughout the life of the rectangle. Okay. So now, why I have given this is, why we made it immutable, just to show another thing here. Okay. So now, what we can do here is, we can say, okay, So in this class, yes, what are the things we have done? Okay, now I'm going to make a change, which is like this. I'm commenting out. I don't want it as a class. What we are looking at is a record. Rectangle is very appropriate for a record. No, you don't put a extends when it is a record. And you are not going to put a extends. But records always have a parameter here. Records will have a parameter. What are the parameters? These are nothing but what will go as instance variables. Okay, and also it will by default also have a constructor which matches my parameters. It will automatically do the initialization for me. Okay, so if I write like this, that's as good enough. Okay, record. Now the things about a record. So this is nothing but I'm converting a class into a record. Record is nothing but a special kind of a class, okay, where the instance variables cannot be specified in this manner. We can't write instance variables and say, oh, I want to have these instance variables. No, you can't have this. Okay, something like this is not allowed. Okay, fine. Again, what exactly happens is when I declare these parameters, it's going to create a class. Okay, it's just like creating a class only, where it will have variables called length and width as instance variables, which are final. Whatever you specify as parameter are going to become instance variables also, and those instance variables are final. So it is immutable class. Okay, fine. The variables for a record are always final, even if you don't mention them. Oh, anyway, you can't mention the instance variables. It can have static variables, but no instance variables. You can't declare in new instance variables. Whatever parameters are there, they are the instance variables. Okay, it will automatically get a toString method. It will have an appropriate toString method. We'll see what is the toString method we are getting. You can have static variables, static methods. You can add new methods, right? You can add methods like area. Okay, you don't need to have the method like getLength. Let's see this. We do not require these methods called getLength and getWidth. Okay. And instead of these methods like getLength and getWidth, I automatically will be getting a method. Find the automatic methods which I'll get. Because it's a record, okay, the methods which I'll get. Okay, so it will be something like this. It would be creating a method like this. It will be creating a method to return an int value. The name of the method will be length. So we would be having a method like this. Okay, so if you want to, it's equivalent of the getLength method which we have written. So we will have methods like length and width because we have specified two parameters. So every parameter you have specified, there's a method to return its value. Method is having the same name as the parameter name. Instance variable, same name as the parameter name. Okay, oh, we have the static block, these are all okay. But yeah, as far as the constructor is concerned, okay, you can write constructor of your own also, but even if you don't write a constructor, the constructor will with two parameters will come. Okay, so I can basically also do this. I can add the other constructor like this. Yes. So I could have actually done this also. This was also fine even if I didn't comment it out. But by default, it's going to get this as a constructor. Okay, so no need to even specify. So if you only want a constructor with the 2 parameters for the rectangle, there's nothing else to be written. Okay. And toString method, yes, if you want, you can override. But even if I don't override this toString method, there's some kind of a toString method which may be, which is much more meaningful than what was there, which you inherited from the object class. Here, one thing here. So when I'm not mentioned what is the record extending from, okay, I have not specified what is the super type for a record. Basically, there is a class called record. There is a class called record. Okay, so though not mentioned, okay, it, and we cannot mention, okay, extends a class called record. So we have a class called record. There is a class by the name record in the Java library. So anytime you are saying, oh, it's a record which I am creating, it is understood that it is going to extend from the class called record. That's the only way a record is created. Record is always a any record you define is a subclass of the class called record. Fine. Let's check this definition. You can see there's so much of code I've just commented out. Very few lines of code, only because I have some static things, right? The getter methods, oh, I needed an additional method to compute the area, oh, that's what I have added. Length and width, yes, exactly the parameter names. Okay, they are the instance variables. I could have even said this dot length and this dot width. Okay, there's nothing else in the code except for the static block and the initializer block. Okay, oh, you want to override equals? Fine, it would have its own equals also by default. See, equals hash code and toString. These methods it is going to override and give it to us. Okay, you wanted to have any additional method, you are free to have it. Area and display are the two additional methods, but length and width would be methods. Okay, so let's now check what happens to the rectangle class. Okay, fine. See, another thing, with this definition of rectangle, the cuboid is not going to compile now. You can't have a subclass of rectangle. Okay. So the cuboid with inheritance is not going to work. Yeah. Okay. Anyway, let's compile the rectangle class. Okay. I think we did something wrong. Acha, it's the line 44. It says, acha, initializers are not allowed in this. Okay. So we have the initializer block to say count plus plus, which is not going to work. Okay, we have the count plus plus in the initializer, and that's not going to work. Okay, so yes, we can comment out the initializer. We will then have to take it into the constructor. Okay, so which means, okay, but anyway, now what would happen is it won't use the count variable. Okay, count is not being incremented with the constructor. Let's check this. At least we can see that this is compiling. Okay, this is compiling. Okay, and if I use JShell, and if I use the import declaration for the shapes, okay, I can now create rectangle object. Okay, cuboid is not going to be working. Oh, you can see the toString. This is the toString for. So the toString comes as simple class name and in square bracket the name of the instance variable equal to the value, comma, name of the instance variable equal to value. Whatever parameters we had given are instance variables for a record. So record is just a quick way of creating something which is immutable. And a class which is immutable, where all the instance variables you want them to be final. You want to have a constructor exactly like that, right? Okay. See, I'll show you another example of a record. Okay. So here on JShell, I'll create a record here. Okay. So I want to have a public record. Let's call it as a point. I'll say int x, comma int y. And I have not done anything. This is a very quick creation of a point. Now I can create objects of point p1 equals new point, and I want a point which is the origin. So I say 0, 0. Okay, maybe. Oh, there is a toString already. When I have a constructor with 2 parameters. Fine. So what is a record? It's nothing but a class where I will have p1 dot x as a method. It's a method. Okay. So variable, whatever you had given, they are also becoming methods to give you the value. But there's nothing to change the value. Okay. Okay. Yeah, those instance variables are fine. Okay. So just wanted to introduce what is a record. So you should now be knowing, understanding, I know what exactly is a record. Record is nothing but just like a class, but so many ready-made things for me. I don't have to write construct, even if I don't put many of the things. I don't put constructors, it's there for me. Okay. For point, maybe you would be interested in having few methods additional, right? For example, you say, okay, I want to have a method in the point where I can give the transformation which is needed for the point, right? So it can increment both the x and y values, no, not on this object, but create a new point object for me, which is nothing but where it is having x and y values increased by so much. Okay. Okay. So you can apply other things, but one thing, point is immutable. On this point, you can't change x and y, but you could use this to create another point, right? Okay, that can always be done. So you will be calling the construct of point from the from point itself, maybe inside a method. And also you are free to have any number of static variables and static members, and they need not be immutable. That's why the static members are not final unless you mention final. Okay. And so record, here what is a record?
Yes.
Okay. Yeah. So we had an introduction to record. Right? Okay. Yeah. So any questions now? Yeah. So mainly, yes, this is what was the and it was today's agenda was this, right? Now, okay, we have created this rectangle as a record. We can go for cuboid also as a record. the one which is using composition, not the one with the inheritance. Okay, so yes, we can actually go back and let's find, oops, sorry. So we can here, let's open the other cuboid class and update it so that it can be also a record, right? So we would like to have cuboid as a record here. Which one? With the one which is in the shapes, this cuboid here. Right? This is not inheriting from rectangle, right? And anyway, since rectangle is now a record, you can't have a class which inherits from rectangle. Okay, so rectangle we have turned it into a record, and the composition one, right? The one which is with composition. Okay, so I think what I'll do here is let me start a fresh one. Okay, I'll keep the old code. Okay, and let's just put the record here, right? So we'll say, oh, I would like to have this to be a public record. Fine. Now what should it take as parameter? What are the parameters for the cuboid? What does it have? It has, we had to put two instance variables. So if I just put this much, that's also a, fine, that's a cuboid. Now what will the constructor which I'll be getting from this? A constructor which can take a rectangle and an integer value. But I'm also interested in a constructor, so I want a public constructor for cuboid which takes 3 parameters. Fine. And what do we do from here? It's not this, sorry. Yeah, we'll have to say this dot rectangle equal to new and initializing this and this dot. So you can write the constructor, that's fine. Okay, so with this also I'm just having a cuboid as a record. I will have methods called, oh, I also want to have a method called get length and get width, because this would have a method called get rectangle. Sorry, this has a method called rectangle, so I want method called length. It has a method called height, but doesn't have a method called length. How will I have the method for length? Return this dot rectangle dot get length. Oh, not get length. That has the method called length again, right? And same way, we will have a method called width. Okay, so fine. This has now got method called height and rectangle are the methods here. Okay, what are the methods available? Oh, we have used this variable name here as rectangle, So this is a method also. This is a variable, this is a method. And same way, height is a variable, height is a method. Okay. Fine. So you get all these methods here, right? Let's check this. So we compile this. Okay, rectangle was already compiled. We have to compile the cuboid. Okay, so here, yeah, it says that you can't just have this constructor must be invoking the other constructor with two parameters. Okay, so which is what we have not done. Okay, so we don't initialize in this manner. Okay, fine. Let's see how we can write here. We can still write this. What's needed? Rectangle and height. Fine. Pass a rectangle object and second parameter is the, yeah, so this should work. Sorry. Okay. So this should have worked. Okay. And you want to go to JShell. Okay. Fine. I can create a cuboid object. Or maybe I have created a rectangle first. Okay. See, we will know from the toString that this is actually from the record. Fine. The record typically uses those square brackets and the toString. Okay, 7 by 5. Okay. Fine. So this is the record. Okay, I have created one rectangle object and now I want to create a cuboid object. How do I create? So one is I can say let me use R1 and a value 4 like this. Look at the toString here. Right? Within the cuboid, it says in the square bracket, there is a variable rectangle which is nothing but a object of rectangle. Again, the toString of the rectangle is seen, right? And then the height is separated out. Okay, so a rectangle object inside the cuboid. That's how you can see it easily. Right? Okay, and I can also use cuboid C2 equals new, and what we can give? Maybe something like this. When both options, we added just a constructor. We didn't put the constructor with two parameters. It was because that's what it will always get. We said first parameter is a rectangle. So if you want to create an object, give me a rectangle and the height. It's made up of two things, right? Rectangle and the height. And so create a rectangle that you can use to create a cuboid object. Right? So that someone can, if someone has just the three integers, even then he should be allowed to create a cuboid, and that's why we added the constructor. You can see this definition is so short. This is all we have done. Okay, so we have the length, width method. Fine, we could test length, width, height, all three methods are there. And even rectangle method is there. You want to see that? C1 dot rectangle. And it's a method. C1 dot. Fine. Clear? Got idea about what is a record? Okay. Something like a rectangle, it's a good candidate for a record. But we have also defined a class called account, right? In the bank package, we said we have a class called account. There, the balance is going to be updated all the time, and we would like to see that it is getting updated. So in that case, it's good as a class. It's a mutable thing, right? So it can never be a record, because in that, if it was a record, we have three parameters, right? Account number, name, and opening balance. No problem with account number and name remaining constants, but balance has to be something which is to be changing, right? Someone does a deposit or a withdrawal, right? We would be having methods which are making changes to the account objects, okay? And so there we can't try it as a record, okay? And so a record, yes, it gives us some ready-made things and a shortcut for immutable class with just the constructor and equals hash code and the other one, which is toString. And these are by default given to us. Okay, it has some version of all these things. Okay, fine. We'll continue tomorrow. Any questions? Yeah, if you have any questions.
Yeah. For what purpose we should use records and not the direct rectangle kind of objects?
Okay, it's basically
Yeah, so and in addition to that, sir, I have a same question. And in addition to that, I can see like we are using, industry 1.8 or 1.11. So
record is from Java 16. Yeah.
Yeah. So the same question, like for what purpose we are using this record?
Oh, it's a shortcut. Something like you define a class called point, and in point, what do we have? X and Y, and we still would be writing all those methods. We'll be writing the toString, we'll writing equals, hash code, everything. Okay, so it says, okay, you just write one line. You can finish it in one line. The entire definition is in one line. Okay, there are actually other cases, there are other things, other usages of this, which are not yet, they haven't yet come into the Java language yet. Okay, but there is something called a deconstructor pattern, one of the design pattern called deconstructor pattern, where it will be possible for, like it's not yet there, okay, but yes, for example, you might have some place where a record object, from the record object you could actually easily break out all the objects. And, I think it's in the switch case or somewhere, it's going to be useful there. Fine. So there is a deconstructor pattern which is available to be quite easily be able to use the objects which are part of not objects, I'd say the members of the of a given record. They can be extracted quite easily, as if I'm taking them in a parameter of a method or something. Okay, fine. Similar to a concept which is there in Python.
Okay.
So it hasn't yet come, okay, but there are some preview features, okay, which have been suggested. So maybe in a few more releases of Java, so maybe 1 year or so, okay, fine. So then you should be seeing those things getting used more, okay. So it's helped in the deconstructor pattern also. a shortcut. That's currently you can say, oh, it's a good shortcut. Fine.
Yeah.
Okay. So any other questions? Yeah.
No.
Okay. Fine. Then fine. We'll be meeting tomorrow. Fine. I think we'll be able to come.